Okay, so welcome to my series of short video about load calculation, also called manual J. This is my introduction to load calculation video, so it's kind of my first video. And I'm going to try to explain in non-technical terms what a load calculation is and why every homeowner should have a load calculation done for their house. It doesn't matter if it's a 30-year-old house or if it was built last year. There's many benefits to having a proper load calculation done for your house. So first, what is a load calculation? Well, before any home can be fitted with a heating and cooling system, it must first be determined how much heat the building loses in a winter and gain in a summer. The process that calculates heat gain and heat loss is called a load calculation or a manual J. It's the same thing. Now the load calculation calculates the heat gain and heat loss in BTU. Now heat escapes the house in a winter. The process is called heat loss and enters the house in the summer, and that process is called heat gain. Okay, the only reason you put insulation in your house, the only reason you buy high efficient windows for your house, the only reason you're trying to stop air infiltration is to reduce the heat gain and the heat loss. If you live in a 75-degree climate year-round, you don't need insulation because there is no heat gain and there is no heat loss. So that's why we're putting insulation in the house, is to stop the heat from leaving the house in the winter and from entering the house in the summer. Now, how much heat is leaving your house in a winter and entering your house in the summer? You don't know until you have a load calculation. Now, the load calculation will vary depending on your climate, the orientation of your house, the type of construction, the type of windows, the type of insulation, and the R value on insulation, the air infiltration, the location of the duct, the number of people, the equipment, the appliances, etc., etc. So you don't know how good your insulation is if you don't have a load calculation, and you don't know if you need to add insulation to reduce the amount of heat leaving your house in the winter, entering your house in the summer. So that's why a load calculation is crucial to understanding energy efficiency. So let's build a house using a load calculation. So here I've built a house. It's a 30-year-old house in the Dallas-Fort Worth area. Now the attic is a vented attic, and the ducts are in the attic, so they're outside the conditioned space. So we're in Dallas-Fort Worth area, and this is the design temperature we're going to be working with. Okay, so now I'm going to start loading my house. So I need to put a floor, information about the floor. What is the floor? So here we're using a concrete slab with no edge insulation, no insulation below the floor. Next, we're going to be looking at the insulation in the attic. So here I've got about 6 inches of insulation, so I'm going to use R21 of insulation in the attic. Then next we're going to be looking at the wall. So this is a 2x4 house with R13 of insulation between the stud, no board insulation, brick finish, and wood stud. And then my windows, again, it's a 30-year-old house, so I've got aluminum windows, dual pane with thermal break and clear glass. Okay. So next, I'm going to be looking at my air infiltration. So back then, it's a 30-year-old house, so my construction was loose. So I've got loose air infiltration construction type, and then my fireplace loose as well. And then my duct, so as I mentioned earlier, the ducts are in the attic outside the conditioned space. I put the 120-degree temperature in the attic. Okay, and now I'm going to be looking at my load. So this is my load calculation for this house. So this is a 2,900 square feet house. Now that's a single story house. And in the summer, it gains. This house is going to gain 57,791 BTU of heat is entering the house. Now if I want to reduce that number, I'm going to have to do something to my house. I'm going to have to increase my insulation, replace my windows, remove my duct away from the attic, or maybe stop the air infiltration. Which one of these four improvements will have the greatest benefit for me? Well, I don't know if I don't have a load calculation. I think it might be the insulation in the attic, but I don't know the answer to that. Now, if I have a load calculation and we add the insulation, the load will tell us that. And that's where load calculation is a tool that will help you save you money. So same on the heat loss. So in the winter, we're losing 80,714 BTU of heat. So that's a lot of heat that we're losing. So I want to reduce the amount of heat leaving my house in the winter. So how to do that? Well, maybe I need to add insulation in my attic, or maybe I need to replace my windows, or maybe I need to stop the infiltration, or maybe, Now, unless you have a load calculation, you don't know which way to go, because you don't know your load to start with. So that's what a load calculation is. So I'm gonna make a series of small video where we will change item per item. So I've got one video where I'm gonna change the insulation in the attic, and then we'll compare before and after. And I've got a video where I'm gonna replace the windows, so we'll compare the before and after. I've got a video we're gonna stop the infiltration, another video where we're gonna move the duct. So hopefully you'll join me in my series of video. But if you need to order your load calculation, you can go on my website and you go at the bottom of the page, and right here you can order your load calculation. Now I've listed some information that I need to do an accurate load calculation. So thank you for watching that video, and hopefully I will see you in one of my next video.